How mathematics finds order and rules in a complex world. The world is very complex. We can see this even when we look at a single day. We manage our schedule, our family's schedule, and the flood of information and notifications. We also think about how our bodies feel and even about what is in people's hearts. Nature is complex too. Wind, temperature, humidity, and even a tiny speck of dust, or a small change in ocean currents, can quickly change the weather. When many layers overlap like this, it sometimes becomes unclear what is the cause and what is the result. At times like this, the role of mathematics is surprisingly simple. It does not force us to change the situation. It helps us see it in a new way. Instead of trying to make everything simple, mathematics looks for the points that give us clues. Rather than jumping to a conclusion right away, mathematics first examines what is connected to what. It is difficult to say that something is complex only because it has many parts. Whether there is 1 candy or 10 candies, it is still a candy box. What usually creates complexity is the relationship between elements. When relationships form, new properties appear. These are properties that did not exist when each element was considered on its own. That is why we sometimes encounter a whole that is greater than the sum of its parts. Water is a good example of this idea. A single water molecule is not water by itself. We cannot tell if it is liquid, ice, or vapor by looking at just one molecule. However, when molecules come together and the way they form relationships changes, their properties also change. Sometimes they move relatively freely. At other times, they form a regular structure and settle into fixed positions. So even though it is made of the same molecules, it can become a liquid, it can turn into ice, and it can also become water vapor. Here, mathematics looks at those relationships and expresses them as structures. We examine how closely the particles come together, which directions they arrange themselves in, and what kinds of patterns repeat. When a substance is a liquid, its neighbors keep changing, and the arrangement moves and shakes loosely. In contrast, when it becomes ice, a relatively regular framework forms, and it grows into a repeating structure made of ring shapes close to hexagons. Instead of packing the structure tightly, this structure leaves empty spaces. Because of this, ice is less dense than water and takes up more volume. That is why ice floats on water. The question, why does ice float, is easier to understand if we ask how the molecules are arranged, rather than what they are made of. A society made up of people is not very different either. We cannot explain a society only by the number of people. Who is connected to whom, and how often those connections happen, changes the shape of the society. That is why a society is more like a map of relationships than a list of people. Even when the same people come together, a completely different scene appears when the way they are connected changes. Sometimes this view alone does not clearly show the order. At times like this, we add numbers and symbols to turn the structure into something we can work with. When we line up the flow of time on a single line, it becomes a sequence. When we connect how strong or weak relationships are using expressions, they become equations. When uncertainty comes in, we need probability. When something changes continuously over time, we study it using differential equations. When viewed this way, mathematics does not stand on the opposite side of complexity. Instead, we face complex things directly and discover the relationships and structures within them. The world may always be complex, but if we change the way we look at it, we have a better chance of finding our way. Mathematics is the language that helps us understand the world.